Hi, in this lesson, we're gonna continue to talk about tangent, and then we'll be introducing arctangent. We have already discussed that tangent has, domain, range, all these issues, right? As a function, as one of the 6 trig functions, we have graphed the tangent curve from -2 pi to 2 pi. Wait a second. Oh, there, that's fine. That's fine. Yeah, from -2 pi to 2 pi in that interval. And of course, last time I left some questions for you, right? And one of these questions is it 1-to-1, right? Is it 1-to-1? From what we have graphed, right? If you draw a horizontal line test, what are we getting? Well, if we draw a horizontal line arbitrarily, okay, and we're drawing this one, right, which crosses, I should use a thinner. I would like to use a thinner line. Okay, suppose I draw this line, which crosses this piece. Okay, this is one of the green, this is one of the line. Horizontal line, it touches the curve at how many places? More than once. Okay, in fact, the point I've chosen is the, it's the input that gives the output equals to 1, right? It's 1. So this is horizontal line, y equals to 1. So, and we can easily see that from the process we were graphing, right? For each input, there's exactly one output. In fact, it passes a vertical line test, all right, but it doesn't pass a horizontal line test. Okay, it does not pass horizontal line test. So how do we make that narrative? How do we make that narrative, right? So there's so many examples we could use. Okay, so I just want to bring back some of the tables we did, right? Let's look at some of the tables we did. Let's see, what other tables have we done? We've done so many tables, right? Such as, right? Look at tangent 2 pi over 3 equals to -√3. And tangent 5 pi over 3 also equals to -√3. So this example, different input, same output, that could make the point, right? So we have many such examples. Tangent 5 pi over 4 equals to 1. Tangent pi over 4 equals to 1. So we have, so that pair will also make the point that it is not 1-to-1. Okay, so let's go back there. So we're going to make that narrative. We're going to make that narrative. We will say it is not a 1-to-1 function because, okay, so here we can just say tangent pi over 4 is equals to tangent 5 pi over 4. That would be sufficient to make our case, right? Because the reader can see obviously the inputs are not the same, but the output are the same. Okay, so it's not a 1-to-1. Therefore, we should not expect any inverse. Is it increasing, decreasing? Is it increasing or decreasing? What's the definition of increasing? What's the definition of decreasing? Well, this goes up, right? And here is lower. So it's not consistent, right? It's not consistent. So it's neither increasing nor decreasing. It is neither increasing nor decreasing in the domain. Okay, in the domain, in the entire domain. Okay, so what is the domain? Right? The domain, of course, is x. The angle cannot be odd number multiples of 2k plus 1. It cannot be odd number multiples of pi over 2. Okay. But it is increasing on a smaller interval. For example, it is increasing from -3 pi over 2 to -pi over 2, right? And it is increasing from -pi over 2 to pi over 2. It is increasing from pi over 2 to 3 pi over 2. So we have these intervals that the function is increasing. But, right, tangent function is increasing in the interval -3 pi over 2 to -pi over 2. -pi over 2, right? And it is also increasing in what else? There are many, many intervals, right? From -pi over 2 to pi over 2, right? It is also increasing from pi over 2 to 3 pi over 2. There are all these intervals, so we can keep going making that description, right? Etc. 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 Even odd. If you look at the homework questions, right? If you look at the homework questions, and you probably have recognized it is. I'm holding on for to respond to that word. Is it even or odd, right? Look what we did, right? When we were doing the tables, we did points from 0 to 2 pi, and we did a -2 pi to 0. What have we discovered? Right? So let me, you can look at those tables, right? And let us also look at the unit circle. Let's also look at the unit circle and the graph, right? Which one shall we look first? Let's look at the graph first, right? Let's look at the graph first. Even function will have the feature that opposite input produces the same output. We certainly don't have that, right? For example, if we look at opposite inputs, right? Input, the orange color, say I have input, hold on, I need to make it thicker, right? Suppose I'm looking at input, opposite input. So there's input here, right? And there's the input there. Okay, it's about pi over 3, -pi over 3. And what are the outputs? The outputs are, there's an output here, there's an output there. It looks like for opposite input, we have opposite output. So that is actually odd function, isn't it? So we cannot possibly have even function here, but we have an odd function. Is it true? Is it true? Because it has to be true for any inputs, right, in the domain. So let's look at another scenario. So suppose I have input here, right? And the opposite of that input is right here, the opposite input. What are the output? Here's the output. And here's the output. So opposite input produces opposite outputs. That confirms it is odd. It is odd, right? If we look at those values on the table, right? We obviously see that. Let me bring up some tables just for the comparison, okay? So we've done these from quadrant 1, right? For quadrant 1, what have we seen? Quadrant 1, right? For quadrant here. Right, so we have too many examples of this sort. So in quadrant 1, right? And let's look at another quadrant. Remember we did that table of a negative, right? Quadrant 4, 3, 2, 1 in that order. So there. I think I'm finding it. Quadrant, not this one, quadrant 4. So now it's 4. Wait, where's my 4? There, this one. Okay, I think I'll probably just copy all of this. Okay, and so we can have a comparison. So if you look at the quadrants, this is a quadrant 1 where pi over 6, pi over 4. For quadrant 4, right? For quadrant 4, what do we get there, right? Opposite inputs, negative pi over 6, negative pi over 6, their output are opposite, right? Pi over 4, negative pi over 4. Opposite input, opposite output, you see? And this comparison can be done, we can keep going. We can just keep going, right? And for this piece, right, we have another set, right? So I set up homework in that order as well. Okay, so I'm gonna just bring all of these with us. Right, so quadrant 1 and quadrant 4. And so we can make all these matchings now, right? So there. Quadrant 2, this piece, right, goes with that. Right, we can forget about the quadrant now. The opposite inputs, opposite outputs. You see, opposite inputs, opposite outputs, right? √3, negative √3. Opposite inputs, opposite outputs. Okay, we have so many examples of this sort. And next one. 7 pi over 6, we have 7 pi over, we definitively have that right here, right? 7 pi over 6, I'm gonna just put it over here. So that's a pair, right? Negative 7 pi over 6. So we just have plenty of examples of this sort. And these are definitively in your homework. So we have confirmed this is odd function. This is odd function. Okay, too many examples. But all of these are just verifying. And from the curve, you can see that is true, right? So we draw the conclusion that tangent is odd. Okay, so tangent is an odd function. Okay. Increasing, decreasing, we talk about now from the perspective of the unit circle, right? We talk about from the perspective of unit circle, what do we see, right? You can see when the inputs are opposite, right? Say I measure an angle counterclockwise, and I also measure the angle clockwise, right? They're opposite inputs, but the ratio of red and blue is going to be opposite, because here you have a positive, right? Here you have a positive, negative. So they're going to have opposite ratio. So it's opposite input produces opposite output. So tangent is odd. Now we finally could focus on our attention on arctangent. Okay, we have talked about it is not one-to-one. Okay, it is not one-to-one. All right, it is not one-to-one. And then what? Then what? Right? We want to create, right? We want to create a new function, right? It is not a one-to-one. And therefore, we want to create a function such that it could represent from ratio to angle, ratio to angle. So you see tangent, right? Tangent is from angle to ratio. And the new function we are about to create, okay, is going to take a ratio, okay, as input to our new function, right? To our new function, we call it arctangent. Okay, so the input are ratio, the output will be angles. But we obviously cannot allow it to be any angles, right? For example, if we have a ratio 1, right? From the example we just saw, for ratio 1, we have many angles for it. So we have to put a restriction on it, right? We have to put a restriction to guarantee, and this will be a function. This has to be a function. Function means that for each input, there's exactly one output. Okay, so in order to make that happen, so when we do that horizontal line test, since we cross so many, we only want to leave one. So how do we do that? Okay, so what we do is that we're going to only look at the piece in the middle. So we're going to chop off everything else. We're going to chop off everything else. Okay, and on the unit circle, we're going to chop off quadrant 2 and quadrant 3. So we're going to make this piece corresponding to that piece, okay, and make it one-to-one. Make it one-to-one, okay? So let's look at domain-wise, okay, domain-wise. Domain for this new function of tangent, right? Domain for the new function tangent. Let me clean this up. Okay. We know that for tangent, the domain, okay, tangent domain is odd, you know, the angle cannot be odd number multiples of pi over 2. 2k plus 1. We cannot have odd number multiples of pi over 2. Right? And now, what is the range? Domain, range, just all real numbers, right? We've seen that, negative, from negative infinity to positive infinity. So what will be those are the possible ratios. So we want to keep that. So we want to keep the ratio from all, it's going to be all real numbers. Okay, it's going to be all real numbers. So let me find that symbol. It should be here. No, there, not there either. My bad, here, found it. Okay, so the domain is going to be all real numbers for the ratio. Okay, but the output, because we chop it off all of these, right? And we will, after chop off, we have a, let me put it here. Let me do it this one here, okay? This is the old Well, this is the tangent we used to know. Okay, this is a tangent. Since we want to create a new function arctangent, and we're only going to look at this piece and create an inverse for the piece in the middle. Okay, so for that, I'm going to adjust the graph. Okay, so the graph is only going to be from this piece. Okay, and the rest, we don't need them anymore. We don't need them anymore. Okay, so let me see. I need to maybe to put this over here. Wait, I still want you to see the horizontal, the vertical asymptote. Okay, so hold on. Okay, so that's the curve we want. This is the curve from negative pi over 2 to pi over 2. With that, a truncation takes place. We basically have chopped off quadrant 2 and quadrant 3. Okay, so for only this piece, we define arctangent. Okay, so let's see how this piece works. We have worked on this piece, didn't we? We worked on that piece before, right? And I'm going to find that piece that we did before. Okay, we just did it, right? We just did that. This piece, right? We did this piece, right? Over here. So I'm going to bring that over here. That was a tangent piece, right? It's the piece in the bottom beneath x-axis. And we have another piece, which is a positive. Okay, let me find that. We did these so that will make it, that will look familiar to us, and that should help. Okay, I think it's somewhere here. Wait. There, right here. It's right in front of me. Okay. These two pieces. Okay. What are these two pieces? Right? In this piece, we have tangent. From, the range wise from negative infinity to positive infinity. And then we have negative pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3. Okay, so let's reorganize that table. Okay, we have all of these to take care of, right? We have all of these to take care of. And because we truncated, so we only need this piece from, pi over 2 from smaller than pi over 2, and this piece is negative pi over 2 from larger than negative pi over 2. Okay, so we're going to create a table, okay, for a very specific tangent function. Okay, let's see, I don't need so many columns. I need more rows, right? I need more rows. Well, we're going to organize it in such a way. This is A, tangent A, and the points are A, angle first, and ratio second, right? So what do we have? Okay, from A approaching negative pi over 2 from larger than pi over 2, which is going this way. Okay, which is going this way, right? Let me mark it, right? It's just going this way, right? So that's what it was for. Okay, and then we get to negative pi over 3, negative pi over 3, negative pi over 4, right? Negative pi over 4, and negative pi over 6, right? And then we have a 0. And then we're going to have pi over 6, pi over 4, pi over 4, and so I'm going to arrange it in such a way, just hold on a second. I'm arranging these rows, and then I will explain it to you after this arrangement. Okay, on this piece, obviously it's an increasing function. Okay, and the next piece, of course, it approaches pi over 2 from smaller than pi over 2. Okay, what is this referred to? This is arrangement from negative infinity, negative pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3, and all the way approaching pi over 2 from smaller than pi over 2. So that's what we're doing. Okay, so let me see if I can fit this picture right next to it. Okay, so what we have selected is from left to right, selecting all these points. This is an increasing function. It is also one-to-one function. It has inverse. And what is this function, right? This function is tangent between negative pi over 2 to pi over 2. Okay, so just that piece after truncation. Okay, so this is the tangent. So this piece, we have inverse, right? So let's see, before we do inverse, let's look at what's going on. When A approaches negative pi over 2 from larger than it, and we know this is approaching what? What does it approach to? This approaches to negative infinity, right? It should be the golden color. Let me use the golden color. Okay, that's the golden color. When it approaches negative pi over 2 from larger than pi over 2, and the function's value it's approaching negative infinity. So on this piece, tangent A is approaching negative infinity. Okay, there's no specific point here then. Over here, we know that tangent negative pi over 3, we already did those many times. Let's go over this one more time. And this is going to be equals to negative root 3, right? We did them before. So this is going to be tangent negative. Just do this with me one more time. Right? The more we repeatedly doing this, the better off we're going to be. So this is equal, and this is, let me make sure I write it down properly. And tangent negative pi over 6. And that's going to be equals to, and of course we know this is an odd function, right? This is an odd function. So this is going to be root 3 over 3. All right, and tangent is 0, of course, that's a 0. Tangent pi over 6, so we can just, I'm just taking a shortcut, right? Because I know this is an odd function. It's root 3 over 3. Tangent pi over 4. Tangent pi over 4 equals to 1. And tangent pi over 3. And that is equals to root 3. Okay. And last but not least, when a approaches pi over 2 from smaller than, which we're very clear about it, is that when our angles approaches pi over 2 from smaller than pi over 2, and the ratio of tangent approaches positive infinity, right? We've seen that many times. So with that said and done, we know this piece is going to be tangent. That ratio approaches positive infinity. Okay, so we are ready to create our arctangent. Okay, so this is a point, right? We have input, output, input, and input, output. Oops, not -2. Input, okay, negative pi over 6. Output, negative root 3 over 3. And over here, it's a 0, 0. Input, pi over 6. I know you probably guess you probably guess it right? Feel free just to move forward to see if you guess it right. So this is pi over 4 as the input, and the output is 1. And the next one, which we have pi over 3 as input, and the output is square root of 3. There we go, right? And this direction goes to negative infinity, goes to positive infinity. With that done, right? Now we're ready to create our arctangent. This is a very important function. Okay, so we're going to see how exactly it is created. Okay, so I'm gonna make a table again, right? But this time, right, the input for tangent is angle. So now the input for arctangent are ratio. Okay, ratio, right? Ratio. Okay, and ratio can be any real number. Okay. So I'm not going to do these yet. Okay, I'm not going to do these yet, but I'm going to do from first one, right? We swap input and output. So output becomes input, and arctan input of negative square root 3, that's equals to pi over 3. You see that swap, right? Swapping input and output. So of course that ratio is x, right? And for this second line, the input is going to be ratio -1, and the output is going to be arctan of -1, that equals to negative pi over 4. Notice that our domain is from negative pi over 2 to pi over 2 for this tangent, okay, after we truncate it, okay. And this piece, that output in tangent become the input for arctangent. So arctan, and that's going to be equals to negative pi over 6, negative pi over 6. Right, you see one by one, this is a one-to-one correspondence on the special angles, special terminal. Then you say, what if it's not special? If it's not special, we got our calculator. Program has been designed to handle the non-special case, right? And the input output swapped, right? Input becomes output, output becomes input, right? So here the output is negative, okay, negative pi over 3. Okay, could you guys please just pay attention to this? It's not very exciting. I know it's not as exciting as, you know, having fun at the beach. But if you just dutifully going through this process, and you're not gonna miss, you're not gonna lose many points if you just get yourself familiar with this. Easy to do and easy not to do. Okay, and for this one, swap after swap, it doesn't make any difference, but there's still a swap between angles and ratio. So keep going. Root 3 over 3 now is the ratio, and arctan of that ratio is going to be equals to pi over 6, right? You can see the swap. You can see the swap. Input and output swapped, okay? Input and output swapped. So that's the implication. That is the implication. This is 1, wait, 2 here. So arctan of 1 is equals to pi over 4, right? So if you talk about how do I write them, yes, the way I put them on the screen, that's the way you write them, okay? You will see lots of these expressions in your future exams and quizzes and so forth. And this one, root 3, now is the input for arctangent, right? Root 3, and that's equals to pi over 3. Right, you can see that swap done point by point. Okay, the swap is done point by point when we're making. Okay, so now to the end of it, right? What happened with these two swaps? Well, obviously the ratio, when ratio approaches infinity, right? Because tangent is a ratio. So when ratio approaches infinity, what happened to arctangent? Arctan approaches pi over 2. Okay, you can see on the limit part, it approaches pi over 2 from smaller than pi over 2. From smaller than pi over 2. You see that? This part, the ratio, when the ratio approaches negative infinity, okay, arctan of that ratio approaches negative pi over 2 from larger than negative pi over 2. You see, the whole thing is swapped. The whole thing is swapped. So let's plot these points, right? We have the green dots plotted. We have the green dots plotted. So shall we plot those other points? Of course. Okay, so we're gonna see when we're gonna bring this picture, right? So how about we just plot them over there? I'm gonna put this, put it in the middle, right? We can put it in the middle. So this way we can have more, we get to see more, right? To swap the point, and on this side, right? And the first point we're gonna, wait. So we're gonna plot these points. Okay, so let's we're gonna have to choose a color. We're gonna have to choose the color. The first point is negative root 3. Okay, and the angle is a negative pi over 3. Okay. Well, actually the gold color is fine. Okay, so let's see how it looks. Let's see how it looks. the gold color. Where is it? -√3. It's probably outside. Yeah, that's the thing. We have to make the picture a little wider view. Okay. There, the gold color. But those other tangent is not supposed to show. Okay, they're not supposed to show. So right now, just ignore them. Just ignore them. Okay. I will explain. Okay. So now the next point is -1, -π/4. So the gold color, I'm going to choose the gold color, which is actually fitting for, because angles are the arc length, right? The arc length. So we have another point here. And so we're just going to plot point by point. Okay, and then we connect the dots. I know right now it's a little hard to see, just follow me. Okay. There. Do we see another point? Yeah, you see the gold color. You see the gold color points, right? And 0, 0, of course, we're gonna have that 0, 0 gold color point, and just a few more points to go, right? So gold color, and here to make you see better, I'm just gonna make a little bit arrangement. Maybe make this just a little short, change of scale, just a change of scale. Okay, so you can see the gold color right here. And next we're gonna plot this point. And you know it's gonna be on the other side. Right? We're gonna add this point, add another point, right? So this is gonna be 1, this is gonna be 4, one more, and this is gonna be √3. And this is a π/3. Okay, I think that will do. You see these three, you see these dots. Now it's time we're gonna connect these dots. We're gonna connect these dots, right? Connect these dots is arctan. We're gonna make it red. Here we go. That's the red. Okay, so this black with the green dots, that's tangent, and the red is the arctangent. It's actually going towards in this direction to very far away, but they're bounded by π/2 on the top and -π/2 in the bottom. So they have horizontal asymptote. Okay, so I'm going to have that π/2. Okay, π/2, we're gonna have broken, and gold color. Let's use a gold color for the horizontal asymptote for arctangent. Okay, I will show you the whole picture, just a second. So π/2, this is a -π/2. We're gonna have it there. And the gold color, broken line, there. Okay, these two gold colors are mainly from the table. One is -π/2, which is at the bottom, and the other one is π/2, which is on the top, If I give you the whole picture of tangent and arctangent together, okay, so that's what we're about to do. So let me show you this. I know you get this picture very nicely done with your calculator, but right now I want you to see that if I properly make the ratio, right? Now the ratio is not right. Okay, the ratio is not right. So this is a 1, this is a 1. So we need to make it closer like this. Okay, so this is 1, this much is 1, this much is 1. What you see here, right? What you see here, this piece, red piece, okay? I think I'm gonna just do something. I will show you here. Yeah, I think what I'm gonna do, just make it like, okay, no big deal. I will just have to cross out some stuff. Negative 5, 5. Okay, so we see more of tangent. We see more of tangent. Okay, but what pieces are inverse to each other, right? That's the thing. You see, the way we created this arctangent, right, which is the red. For this red, it has an inverse. It has an inverse. So I'm going to just make some adjustment to the scale. So I want you to see that symmetry. I want you to see that symmetry. You see the scale is not, this is 2. Let me do this, okay. Make it 3. Let me come back with 3. Okay, see that will make it better. Yes, this is better. Okay. Which piece of the functions that are inverse to each other, right? Apparently, right? First, let's remove these pieces. Okay, I'm going to remove these pieces. Okay, that's not the tangent from which we create the arctangent. Wait. All right. Why it doesn't go away? Go away. Okay, so I'm putting these away. How come it keeps coming back? Okay, I'm going to do this. Okay. Oh. Okay. That's not bad. Right? Okay. I just want to show you that piece that are inverse to each other. There. There. Okay. I'll just cross you guys out. Disappear. Okay, I make them disappear. Okay. So even though this is not perfect, but these are the two pieces that are inverse to each other, and they're symmetrical about the line y over y equals to x. That a green line. That's a line of symmetry. That this function is symmetric about, is symmetric with respect to. Okay, so these two are the inverse function to each other. How about the pieces I cross out? Okay, those are the actual tangent, right? So you can see there's a small piece that we find inverse function for, and that inverse function is a red. So that's a tangent, right? You can see domain is from all real numbers for the red, right? So this is arctangent. This is arctangent. Oh, this is too thick. I thought I could get by, but it's not going to make it that way. Okay, so this red is arc 10. Okay, its domain is from negative infinity to positive infinity. And its range is from negative pi over 2 to pi over 2. So its range is right between these two. Right between these two lines, okay? And the line on the top is y equals to pi over 2. And the line in the bottom is y equals to negative pi over 2. Okay, I hope that's clear to you. But then you say, well, if you ask me, if you give me tangent, which tangent are we supposed to know? Well, whenever tangent is mentioned, it's always referring to the tangent, which has a domain, which is the domain is not odd number multiples of pi over 2, unless otherwise specified. Unless otherwise specified. So now let's summarize. Okay, let's summarize. Okay, so everything is back, right? So what are we talking about? All right, we got it done. Okay, summary. Okay, so first of all, we have a table. I don't think we need many rows. So the tangent, as we know, right? It is a function that takes angles and produces ratio. Okay, it produces ratio, and those ratio can be any real number. Okay, produces a ratio. And arctangent, okay, takes arctangent, takes ratio, produces angle. Okay, so arctan produces angle. Okay, and those angles are going to be from where? They're going to be from negative pi over 2 to pi over 2. To pi over 2. Between these two lines, you see the red between two golden lines. The line in the bottom is pi over negative pi over 2. Pi equals negative pi over 2. Y equals negative pi over 2. The top is y equals pi over 2. So let us mark it. Okay, it's very important that we understand that. Right, so we're gonna write y equals to pi over 2. And that is going to be -6. I think that should do the marking properly. Okay, so this line is pi over 2, and there's another line, okay, which is y equals to negative pi over 2. They're both bounded. Y equals negative pi over 2. There. You see the red curve is bounded between the two lines, the two horizontal lines. In other words, it is between these two. Okay, it is between these two. Okay, that's the range, the vertical span. Horizontally, the horizontal span for the red curve is from negative infinity to positive infinity. It goes on and on forever. Okay, now with that said and done, let's move forward to continue our summary. And this ratio for tangent Can be any real number. It can be any real number. And the angle, right? It can be any real number other than the odd number multiples of pi over 2. Okay, so arctangent, right? You see how different domain, range, and this ratio, right? This ratio here, it can be any real number. The ratio here can be any real number. And the range, however, is from negative pi over 2 to positive pi over 2. It's just a strip. All right. Okay. Picture-wise, we saw the picture. Arctangent. But what is the inverse to arctangent? Okay. What is the inverse to arctangent? So suppose if I put f of x equals to arctangent, what is the inverse of it? The inverse of it is tangent, of course, but, okay, its x is from that open interval from here. There. Okay, so instead of that as input, right? So if I put these together, over here, the domain for A, right, is going to be from pi over 2. So that would be from there. So that's the difference. But anytime we talk about tangent, we always refer to this tangent. And we're not referring to this tangent unless otherwise specified, because whenever this tangent is referred to, it will always be in the situation of otherwise specified. Okay, so let's draw these curves separately, right? Tangent. I think we should do this, okay, because we spend so much time drawing these curves, right? We're just going to, you know what? I'm gonna dig back our past, right? So this is the tangent. This is the tangent. Right? This is the tangent. As we know it. This is a tangent. We've done so many points, right? How about arctangent? If we draw arctangent separately, which we can do that, right? Let's draw arctangent. We just draw that curve by itself. We just draw that curve by itself. How does it look like? We're going to make it red, right? So we can see the correspondence. And we're also going to just make some adjustment. These are things at your fingertips, right? We just need to know the details. And the view is from, that should be, I think that should be fine. Okay, that should be fine. So I'm just making some arrangement. Okay, and so that they can be comparable proportional wise. Okay, so I'm gonna cut it. Whoops. Before I copy and paste, right there. Okay, so now I'm going to put that horizontal asymptotes, right? Pi over 2. I will still use that broken line, the sienna color, and the other horizontal asymptote right there, right? So we see these horizontal asymptotes And of course, I could have put the points there. We could, if I could leave that for you. Right, if I can leave that for you. You see, that's arctangent. So this way that the graph is kind of comparable, right? So the input, this piece has the inverse, which is the red, right? Just this piece. Okay, only this piece has the inverse, which is right here. That inverse is right here. Okay, so this is the inverse to each other. Now, for that piece, we describe it as right there, okay? So what I'm gonna do is that I'm going to do the following. I'm gonna take this piece and shrink it. Okay, just going to shrink it. Make it 8. So that way should shrink it well. Okay, so they're kind of comparable scales. Okay, they're kind of comparable scales. But we do see that we do see it clearly as a summary, so that it carries enough information. And this piece, I can make it a little narrower, but not much more narrow. Okay, so from input-output perspective, we see all of that. Okay, so these two are inverse to each other, but we rarely talk about this. So this piece is rarely mentioned unless otherwise specified. We usually just pretend this doesn't exist. Okay, pretend this doesn't exist. If we could put the points on these places, that would be nice, right? Shall we? I think we should use the, well, after that, we're gonna take a break. We're gonna just end this recording and do another one, okay? So how about we review this piece, right? We're gonna put the points in this picture. So what are those points, right? Remember, we have -√3. Remember the second table, right? Hold on. -π/3. If I can make you recall, right? What color did I use? Red. Right. So I mainly want to put the dots over there. Okay, we did that table before. I think we did that table over here. Right? We did that table. So I basically want to put these points on that chart again. Okay, so this way we can have really a good view. If you can mark those points, it would be even better. If you could mark those points, that would be even better. So this one, it's not going to take too long. This is divided by 3. And this is 6. And next one, it's going to take no time. Okay. And the last one, that's going to be 1, -1, π/4, -π/4, and one more, +1, +π/4. So odd function. So there we go. So if you can mark all of those points, right? If you can mark all of those points, this point is -√3, comma, -π/3. This is -1, -π/4. And that one is -√3/3, comma, -π/6. And 0, 0. And root 3 over 3 comma pi over 6. And this is 1 comma pi over 4. And this one is root 3 comma pi over 3. You can see the correspondent. We have done all of those points. Guess what? I will quiz you and test you. Okay? I will quiz you and test you. But anyway, without further ado, I think this lesson is long enough. I will see you another time. Thank you for watching.